how to code up the Girls Programming Network Scissors Paper Rock Intermediate Workbook. Yep, we're going to have a go through the workbook, see the code that comes out at the end. Thanks to everyone who helped put this together. And we can see this is our intermediate workbook here because we've got a little computer in the corner. It's our sneaky way of tutors being able to know what level the girls are working at and to make sure they have the right workbook without the girls knowing they've been leveled. So beginners, intermediate, and advanced. So let's take a look at this intermediate workbook. So some of the intermediate classrooms will still do the Intro to Python lecture at the start. So they'll start with that and cover print and input and comments and things to get them started for the day. But some of the classrooms will go straight into this. So we'll be using an idle in the classroom, so I'll show you how to get set up in idle. So we've opened idle, we can make a new file and we can save that as scissors paper rock intermediate.py, and then we're going to add our comment. This is Renee's intermediate scissors paper rock, and we save that, and then we could run it. So you can run it using F5, and then we see it ran and nothing happened. Yeah, awesome. So I'm actually going to switch us to a different editor because this one is definitely going to crash during this taping. So I'm just going to switch to something that won't crash, and I'm going to start off here with a scissors paper rock. I'll work in there so I don't have to edit 50 different bits together for this video and have it all jumping around for you. So we have created a file, we have put a comment in it, we've run it. Excellent. That means if we tick all these red boxes, we can move on to the next part. We don't want the kids jumping ahead because each part will build on the previous one. There'll be some optional activities, which I'll go through later, that they can do along the way, but they need to do everything in the red box to make sure they're ready to do the next part. Okay, cool. So let's print something to tell the user that they're playing scissors, paper, rock and the rules. So we want to print out this blob of text, but that's going to take a really long time to write. So we can actually just go to this link. You guys will have a link like this too. And we can copy this, and there's two different ways we could print this welcome message out. So the easiest way, well, the quickest way is to just print it using a multi-line string, which is 3 quotation marks at the start and end. It means you can do it over multiple lines, but you can also do 1 line at a time. So you would do this, and you could have print welcome to human versus computer, etc., etc. So get rid of those ones. We're going to go with this easy one for us, but the kids, if they don't quite understand this multi-line string, you can get them to do 1 line at a time. This web page will also have a bunch of different things on it that they can use later as well for their ASCII art. So jump back to the workbook. So let's try printed the welcome, we've printed the rules, let's try running it and see what happens. Oops, that's the beginner's workshop. Let's run this. So you'll run yours still using F5, and there we go. So we've printed the welcome and the rules. Great. We've run our code, we've printed welcome and rules, we're ready to move on to the next section. We played what? Okay, great. So we're going to start actually getting some moves, making the game play. So we're going to start by hard coding a computer move. We'll get on to randomly generating one later. So we're going to start with creating a variable, and we're going to choose one of these things we want it to play all the time. So I'm going to choose rock. So now the computer will always play rock, which is stored in that variable, and we're going to get the human to input their move. So they're going to put theirs in at the command prompt. So I'm going to create a variable called human move, and we're going to use input to ask the user a question. So I'll ask, what is your move? Scissors, paper, or rock. And we're using lowercase letters there very purposefully because later, if the kids tried to input rock with capital R or something, if we don't account for that, it will only work for things that we've programmed it to match to, and rock with a capital R, of course, won't work and won't match rock with a lowercase r. So we've got the human moves now being asked for. The human moves already in there, so we can run the code and it will ask us what we want to do. So I might want to play rock, and now it asks a question and it doesn't do anything, so should make it do something with that. So let's start out by making it print out the moves. So once we've got our 2 moves, we can print out that we want, like, that computer played, and then we can use a comma. We'll put in that space automatically for us. Computer played, and then we do the computer move. Put in that variable, and we can do the same for the human. Human played and human move. Cool. Let's see how that looks. So I'm going to play scissors. And it says computer played rock, human played scissors. Awesome. So we've got our moves. So we'll check off that we have set a move for the computer, asked the human to put in a move, printed out the moves, and we've run the code. We also have some extensions they can do here. So we saw at the top there was that blue arrow. Here's another blue arrow. It tells us where the lectures need to go. So the kids won't be able to go through past this point until they know something about dictionaries. Maybe a few will already know that, but most probably won't. So they'll need to hang out, and maybe some of the people have got ahead of the rest of the class, and we'll need to give them something to do. So we can get them to do these purple activities, which aren't necessary to go on to the next part, but they, are fun things that will make your game more interesting. So you can do those while you wait, and they won't affect the rest of your game. So we can try and add in this not so fast one. So we look and we see we need to import time. So I'm going to chuck this at the top. Import time, which is a module, has a bunch of cool time features, and we can add time.sleep between our print statements to make them, look more like they're coming one line at a time, like the computer is actually interacting with us. So I can do time.sleep. And then we can give it a period of time. So this will be, let's make it 0.2 milliseconds, and we can put this wherever we want. So put it in between all of my prints. And now when I run it, ask for a move, I'm going to play rock. Now it takes a couple of seconds between each one to print, which will be even more interesting later when we have more lines being printed. It seems more interactive. And you can change it to whatever time you want. To make it seem more delayed or super speedy. So that's a fun extension the kids can add. And they can also add the personalize the game. I've just taken out that code so we can keep it simple, so we can see the essential project at the end. So this one we can make it talk to the person using their name. So before we ask for the move, we could ask for their name. So we can ask what is your name, human? And then we can also use that name. Instead of saying human played, we can say name played. Let's see how that looks. My name is Renee, and then I'm going to play rock, and it says Renee played rock, but then human played rock, so that makes it more personal. So that's a fun extension they can add in. We'll just take that one out too. Okay, and we're back to our base game. Cool. So we've done that. We're now ready to move on to part 3. So we can start by filling out this table. So this is just like all the different combinations we could have and what the result of that matching is. So the kids will fill this out in pen in their workbook, and then we're basically going to turn this into a dictionary. So I will, for anyone who doesn't use dictionaries that much, I'll just do a little brief look at them. Hopefully Python will be kind to us, so I can use its shell. Okay, cool. So might have seen dictionaries used before. Could use it to make a phone book. It might be Renee. My phone number is 111. Emma, her phone number can be 222, and Steph, her phone number can be 333. So to get something out of our dictionary, we use square brackets, and we just have to put in one of the names that is in there. So the names are the keys in this, and then the values are the phone numbers. So it will give me back 111. I could assign this to a variable. My number was this. I can then print my number. We'll give it back so we can store it in a variable for using it later. And we have to remember that the capitalization is always important. So if I do my dict and I give it Emma with a lowercase, it gives me a key error because we actually defined Emma with an uppercase letter here, and Emma with lowercase doesn't exist. So we'll throw this error if they haven't defined something in the dictionary and they can't look it up. So we can do that. That's our kind of regular dictionary setup that lots of people will have used before, but we are going to be using tuples in our dictionary. So a tuple is a set of objects. They can have as few as one item or less, but we're going to do ours with pairs of items. So those are going to be our human move and our computer move. So a tuple could look like this. It could just be 1, 2. That would be a tuple. 1, 2. Go type of A will tell us it's a tuple. It's like a list, but it's immutable, so you can't add anything to it. Like you can't do append like you would with a list. It's basically a fixed list. So we're going to be using tuples to store our human and computer moves combined as one thing, and the corresponding result of that pairing as the key. So as the value, sorry. So the key will be the combination of human and computer move, and the value will be who wins from that. But let's look at an example first of how we can use tuples in a dictionary. So we might want to store locations of some famous landmarks or something. So I'll just make up some lats and longs. So maybe we would have 180 and 35, and that might be the, Arc. What else? What can I spell? Arc de Triomphe. No idea how to spell that. That's my spelling of that. And then another location we might have 180 and minus 56, and that could be Harbour Bridge. And then we might have at another made-up location, 150 and 30. That could be the Sphinx. Also not how you spell the words. Close enough. Okay, cool. So we can see we've got a pair of items matches up to a fake location, or a real location at a fake spot in the world. So now we can use the locations and we can put in that pairing, and it will give us back the Arc de Triomphe. Cool. So we can use the same principle for our game. So let's go back to our code, and we're going to turn our table here into a dictionary. So we're going to call the dictionary results, and we're going to create a pairing for each row in this table here. We're going to start with scissors, and then the result of that is going to be tie or draw, whatever you want to call it. We can go again. We're going to have scissors. We're going to have paper. And the result is human wins. going to copy this because this is going to be a while. And I think we can split this over multiple lines because otherwise it's going to be a bit hard to read. Okay, we're going to have rock here. And let's grab this whole line, including our line break. 1, 2, 3. Okay, that should be 9. So we can have paper. These ones can all be paper. And these will be rock. And we're just getting all the combinations which the girls will have written into their tables. And now we have to work out who they would win. So computer, and we're going to have to remind them that the order is going to be important for these. So we see we've got, you know, rock and paper and rock. Those are actually like, you know, the opposite results. So we're going to make sure the girls remember that you can't interchange scissors and paper and scissors, because one is the computer move and one is the human move, and the human move is always first. So that's a tie. This is human. Then we get human. And then computer. And then rock and rock. And that finishes us off. Great. Okay. We now have our table. So now we've got that, we can look up. We already have our human and computer moves, so we can actually look up who's the winner already. So we're going to store our winner in a variable, so get the value using the key. So the key is going to be our human move and our computer move, because that's the order we put them in our table. And so we're going to have winner is equal to results, and then we're going to put in our human move first, and then our computer move. Then it will look up in the table who the winner was. And we're going to print out the winner so we can see what it's like. So let's give that a run. I'm going to, so currently the computer's playing rock all the time, so I'm going to play scissors. Which is silly because I'll lose. And we see that the computer is the winner. We can do that one more time. So it's going to play rock, so I'm going to play rock too to get a tie, and it prints out tie. So it is printing out the corresponding value from here. Okay, cool. We probably won't want this winner line in our next, actually let's leave that winner in for this moment, and then we'll make it prettier later. Have more interesting parts. So those are our main parts of this part. We've created a dictionary, we've checked who's won and put in a variable, and we've printed it out. And now we also have this bonus option here, which is to make it deal with when the human doesn't enter correctly using, you know, only lowercase letters. So let's have a quick look at that. So we've got our human move, and someone might enter rock in all caps or something. So we want to make sure it's all in lowercase, because our table here only knows the lowercase words. So we can do human move equals human move dot lower, and the dot lower will turn our word into the lowercase version, and then we just override it and put it back in that variable. So now if we play again and I put in rock, something like that, it will turn it into rock. Cool. So that's a nice extension for them to try. I'll just grab that out and go back to our basic version. Cool. So let's have a look at making it print the winner better. So we're going to use an if statement to make this winner printing more interesting. So let's get rid of this one, and we're going to have a different thing if it was like someone won, and something different if it was a tie. So print, start with an if statement, if winner equals tie, then we want to print It's a tie. Yay, very exciting. So let's give that a go. I'll play rock, we get a tie. It's a tie. We play again. I play scissors. And nothing happens because we haven't programmed that part in yet. So let's add in our elif. So winner equals human. Maybe you want to print something like the computer is angry for losing. You win this time, human. And we could print something else. So the computer's now won. It's pretty sassy. Let's print wah ha 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 ha. Cool. So we've got a few different options, so let's give them a go. I will play, this computer is playing rock. I will play scissors. And the computer will win. Print this sassy message out. Play again. I will print paper. And tells me I won this time. And we saw the tie work before already. Cool. So we have done different things for if it's a tie, the human is winning the game, and the computer wins the game. We went with something slightly sassier than these messages, which the girls should be encouraged to do. So, cool, we've got something that prints out the winner now, but we always know how to win because the computer always plays the same thing. So let's add in some random variation. So we're going to start by, at the top we're going to import random, and we're going to use that here on computer move. Instead of just having rock all the time, we're going to randomly select from a list. So we're going to do random.choice, and this just chooses a random item from a list. So we've got 3 options it can choose from, and it will just put one randomly into computer move each time we play, something different each time. So let's give it a go. We added that one line of code, and let's get some more room on the screen. What is your move? So it's rock. I'm going to go with rock. The computer also played rock. That's what it had before. So let's get something again. Maybe it will play something different. No, still playing rock. That can happen with random choice. That's okay. Please play something other than rock, computer. There we go. Okay. Computer has played scissors and I have played rock. So this is getting interesting now. So we can just keep playing and it will always play something different. It also played paper. So yeah, we can see it's making random choices now, getting a bunch of different results. And our game already works, the rest of it. So now it really looks like a real scissors, paper, rock game, which is pretty cool. Cool. So we've made our random choice, and it plays different moves and prints a different winner each time, which is awesome. Okay, cool. So here's another bonus one we can do while we're waiting. The next lecture after this will be on for loops. So we might have to occupy some kids while the rest of the classroom catches up. So what we're going to do here is, grab one of these. Where's our pictures? Here are our pictures. The guitar's gone crazy because of the small screen I'm casting this on. Okay, cool. So we can add these in at the top, just chucking these big pictures in some variables. So I might go rock, pick, equals this, scissor, pick, equals this, and we will have paper, pick equals we've put them in variables rather than just printing them out by themselves, because we have to use them multiple times when we want to print the same kind of pictures for computer and for human. We don't want to have those big pictures in the middle of our code, so chuck them at the top. So now when we play the moves, we can, let's go in here. So after the human move, okay, we chuck in an if statement. If human move is rock, then we want to print rock pick. If it's paper, we want to print the paper pick. And if it's scissors, scissors, no, human move, it's scissors, we want to print scissor pick. Great, and we can do the same for the, we put them in the wrong place. I'm going to cut this out, I'm going to chuck it in here. We can do the same for the computer. Computer move, computer move, computer move. And let's see how that looks. We need lots of room for this one. On this, okay. Print rock. Computer played scissors and I've played rock, so we get these cool pictures. Let's play one more time. Then we'll get some paper. I will play paper. We see all our different things, which looks pretty cool, and I think the girls are going to love that stuff. So we now have pictures as well. We'll just take those out because that's a big chunk of code, but that's how those will work. If the girls get up to that, I think they'll really enjoy doing those ones. So let's get rid of these two. Cool. So we're back to our base game, and let's go and look at the next section, which is again. So this is where we want to play multiple times, and we're going to get the girls to make it a fixed number of games. So how many games do we want to play? We're going to start by asking the user to input how many games they want to play. So we're going to do this here after they've read the instructions. We're going to call it num games, and we're going to make it equal to the result of the input, which will be how many games. So ask them how many games they want to play, and we remember when we did input to get the move, scissors, paper, or rock, we got back a string of scissors, paper, rock. And the same thing will happen if you ask for a number. So we'll get the string of 3 or 5 or whatever number they put in. But in order to be able to actually use this value as a number, we need to turn it into an integer. So we're going to use int around this function, which will take the value, maybe the string of 5, and turn it into the number 5, which we'll be able to use for counting in our loop that we're about to put in. So we now have a number of games. We can run this and it will ask us how many games we want to play. I might say 20, 36, and then it will ask us to play, but we haven't added in our loop yet, so it won't play 36 times yet. So let us add in the loop. I think we lost one of our prints in the older fun. So let's put this computer played back in. Okay, cool. We're good. So we've asked the question. Now we need to use a loop to make the thing happen that number of times. So we need to work out which parts we want to happen multiple times. So we don't want to ask for how many times we want to play multiple times. So we want to do that once, but everything else, choosing move, getting the humans move, deciding the winner, we want to do that all multiple times. So we're going to put our loop in here after how many games we're asking how many games we want to play. So we're going to use a for loop. So a for loop lets us do something for every item in a list or a string or something, but at the moment all we have is this number num games. So we need to turn this into a list effectively of all the numbers between 0 and num games to make this happen. So we're going to do this using range. So I'm going to say for I in, and I is just a placeholder variable that basically keeps track of where we're up to in this list. So for I in range, which is a function that turns a number into a list of numbers from 0 to that number minus 1. So if I say num games, range of num games where num games is 4, you'll get 0, 1, 2, 3, and we can see there's 4 numbers in there, which means we get to go through them. It takes 4 steps to get through that list, so we're going to do everything in here 4 times, which is what we want. We want to play 4 games. So we want everything we want to be on repeat inside of this. So this is what the next part is about, indenting your code. It's about making sure we have put it inside, because only things inside this loop will get to be run multiple times. So, cool. That looks good. Now we have something that runs on repeat, and now we just have to think about what happens at the end of the game. So, at the end of the game, we can print game over. So we only want this to happen once, so we do it after our loop is finished. So let's give that a go. Okay, let's play 3 games. I'm going to play rock first. If the computer beats me, I'm going to play rock again. I won this time, and I'm going to do paper on my last one. And I won this one too. And then we know the game is over because we have reached the game over step and we've done all the games. So we can say we have asked the user for the number of games. We've done the number of games that many times, and we have got to the game over message. Cool, so that's the whole basic project. That's what it looks like here. Not too many lines of code. This dictionary is pretty versatile. It saves us writing 9 different if statements, which is what we're making the beginners do, because we're exploring this harder dictionary concept, but actually saves us a lot of typing and copying and pasting. So yeah, pretty interesting. There's a bunch of extensions we can do with this. This one's about keeping score. You can just create some variables, you know, num computer wins and num human wins at the start. And then every time the computer wins, you add 1 to the score. Every time the human wins, you add 1 to the score. And then after the game is over, you can compare who's won more games, who won overall, and you can print out those final score tallies. With this one here, this one is about checking that something is a real move. So if someone puts in banana or lamppost, which is not paper, scissors, or rock, you can loop over and over and over again until they put in something that is valid. And then we have this one, which I think the beginners get a copy of this too, but it's going to be much harder for them. But in here, it's a little bit hard, but not unreasonably long. So we currently have 3 by 3 different options for this game. If we want to make scissors, paper, rock, lizard, Spock, we need to have 5 by 5, so we're going to end up with 25 lines of dictionary, but that's not too hard to achieve for a pretty cool game. So that's what that extension is about. So hopefully they have fun with that. And at the end, we also have another extension about writing your own rules. So maybe you don't want to use scissors, paper, and rock every time. You want the user to have to input the different options. Maybe you want cat, dog, and mouse, and it will turn it into this dictionary. So this is some more advanced dictionary work where we create the dictionary on the fly from the things that the user says. To create a customized game experience for everyone. So that's pretty exciting. So yeah, we've got the base game, which is pretty interesting as it is, and hopefully nice and approachable, and we explore some cool concepts in different ways. And then we have a bunch of extensions for the girls that, you know, get through everything, and we've got to challenge them a little bit. So hopefully the girls have fun with it. I hope you had fun with it. And as always, email me if you have any questions. And see you soon. Bye.